So yesterday, if you remember, we said that we use the PSM to answer the question, the impact of specific policy on or treatment or training on an outcome of interest in the income, like wage, like women empowerment, like the children's health or education, in a context where we don't have randomization or random allocation of this program to the beneficiaries. And we started with the PSM method that we said it is in a way of mimicking the random context by eliminating the selection bias based on the observable characteristics. And we said we will send the do files all at the end with all the data set and the presentation. Ramaj will send you everything after today. We said that the major critique of PSM is that it does not take into account the unobservable characteristics, and this can be affecting the selection into the program and also affecting the outcome variable of interest. Today, we will study the difference in difference methods, which is taken into consideration or control for the observable and unobservable characteristics, as we see. However, as you can notice from its name, we need to have 2 points of time of the observations. So you need to have a panel data. Usually we'll have a data set or a survey before a specific program or policy, and another round of this survey after the implementation of the policy, so you can compare before and after. And this is why it's not, if you don't have a panel and if you have only cross-section, you can't use difference in difference. However, I will show you at the end of our session today that we can use difference in difference in cross-sectional data. However, you need to have a clear specification of who is benefiting from the program and who is not benefiting, as we will see. So the main idea of difference in difference, that as you can here, assume you have two group of individuals. One group who will benefit from the program, the treated group, as we agreed to name yesterday, and a comparison group or the counterfactual group. So these two persons, these two groups of persons, before the implementation of the policy or of the training, had different outcome. And assume that the treatment group, the group who will benefit from the capacity building, for instance, already had an income level higher than the income level of the comparison group. Okay? And most of time, I mean, income is supposed to increase with time. So for both individuals, for those who will benefit from the training and those who will not benefit of the training, we assume that there will be an increasing trend, but it will be parallel. So both individuals will see their income increasing. So this income level of the treated group after the implementation of specific program is higher. In any case, even if they did not benefit from the program, it will be higher than their initial income level. And the same thing for the comparison group, their income would be higher than their income before this policy. So without this training or without this policy, these 2 points will be the income of this group of individuals who will be treated and the other one. The idea that we suppose, if we found that the income of the treated group is point B, so assume here this point A prime, and here is A double prime. So here it's at A0 is the initial level of the income of this group A, okay? And here B0 is the initial level of income of group B. Let's say this was in 2020. So before any program, the income of group A was higher than the income of group B. And without any program in 2025, we expect that both income levels will increase, and group A will have a new level of income A prime higher than A0, and group B will have higher income level as well, B prime higher than B0. But there will be parallel. However, if at any specific year there was a training program, so this is a treatment, And group A are the individuals who were selected to benefit from this program. So we found that their income increased to A double prime. So instead of B A prime, it will be A double prime. So the gap between their income and the income of group B is even higher. We can assume that this difference between A prime and A double prime is the treatment effect, is the effect of being, I mean, in any case, their income is higher than group B, but with the program, with the training, it became even higher. However, given that, I mean, yeah, this parallel trend assumption makes that there is difference and there is an equal trend, but because this was not random, because the selection into this program was not random, given that we are not in a random context, we find that the difference between A double prime and the A prime is not only the treatment effect. I mean, all this difference is not related to the treatment effect. There is a part related to the treatment, but also there is a part that is related to a bias, given their characteristics, that it would make, in any case, even without the program, their income would increase from the point A prime to this red point. And this is the true counterfactor. So if I want to know what would be the situation of the group A without the program, without the training, it will not be the blue dashed line, it will be the red dashed line. Okay. Why? Because there are some factors that are changing over time. There are time varying factors that would make that the outcome will be would be different between the two groups, A and B. And this is why, in this case, if we wanted to measure the impact of this specific training or this specific program on the income, we need to take into consideration or to remove this bias to make sure that we have only the treatment effect. Because if we assume that this is the treatment effect, here we have overestimation of the treatment effect. But we need to control first for the bias, for the time varying control factors that would make the income in any case for group A higher than group B. Then we, after controlling for this bias, we can calculate what is the treatment effect or what is the effect of this training or this policy on our outcome variable of interest, which is income. Is it clear, this first thing? Okay.
Yes.
Perfect. Thank you. For this type of, I mean, for data and for having this trend over time, we have we have an identification assumption. The first identification assumption or conditions that should be verified, what we call the conditional exogenality of treatment. We supposed to know that the treatment does not depend on unobservable characteristics that may affect the outcome of interest. If this is the case, we will say that we have conditional exogenality of the treatment, and in this case, we'll be dealing only with the observable characteristics. However, as we said yesterday and today in the beginning, this is not true, because we can have, I mean, maybe group A, even if we control for their characteristics, they have, I don't know, capabilities and skills that are not observed that makes them gain higher income compared to group B. So this conditional exogenality treatment is not always verified. We have a more weak assumption, which is the conditional exogenality of treatment to change in outcomes. What this condition states for, it says that we can differentiate the unobservable characteristics into two things. So we agree that we have unobservable characteristics affecting the treatment, affecting the selection into the treatment. However, these characteristics are, these unobservable characteristics can vary over time, and others are not varying over time. So again, we agree that it is not the condition of exogenality of treatment is not justified. The individuals have characteristics that are not observed, that we cannot control, that would affect the selection into. So as I said, so we agree that we have the unobservable characteristics. We don't have the condition of exogenality of treatment is not verified, but we can depend on the weaker one, which will divide the unobservable characteristics into two parts. A part that it's changing with time. So assume, I don't know, we have skills of how fast we write on the computer, and maybe with time we'll develop the skills So we cannot really observe what make me faster in writing on the computer, but we know that it can change over time. But other unobservable characteristics relating to my personality, my IQ would not change over time. So under this assumption, we can control or eliminate this selection bias related to the unobservable characteristics by saying, okay, we will focus on the characteristics that are time invariant, and we will assume that that if we control for this, we are eliminating the bias. In other words, with the PSM, we controlled for the observable characteristics. Now for the unobservable characteristics, to control for it, we'll divide it into two parts. The part that it is not varying over time and will eliminating by using panel data, because we'll have 2 points in time and we'll be able to eliminate this time invariant observables, but we will still have the unobservable characteristics that are varying with time that we cannot control. So still there will be bias, but lower than the bias that exists before. Okay, so difference in difference allow us to control for the unobservable characteristics in addition to the observable characteristics. It is an addition or a better method than the PSM, but it controls only for the unobservable characteristics that are not changing with time. And that's why we need 2 points in time to be able to control for this unobservable characteristics. Let me give you an example. In Egypt, yesterday I talked to you about the program Takaful. We have another program called Forsa or Opportunity, which is kind of the graduation program from Takaful. So Takaful provides conditional cash transfer, and Forsa provides the beneficiaries of Takaful with training and capacity buildings and access to economic opportunities to graduate them from this program, and so they will start having their jobs and their access to economic opportunities. Assume I wanted to test the impact of Forsa program on the income of the beneficiaries. Again, the selection into the program and the income of the individuals depend on observable and unobservable characteristics. Now, if I have a panel data, assume I have the data regarding those who benefited from the program, who benefit from Forsa, and those who are our treated group. We have also our control group. We have their income at period T0 before the implementation of Forsa, and we have information on their income and their characteristics after the implementation of the program. So I assume I have 2 points in time, T0 before the implementation of my program. I know that the income of the treated group is A and the income of my control group is C. For after 2 or 3 years of the implementation of the program, I have the income of T1 and at period T1, B for the treated group and D for the control group. If from the beginning, if I return back to the parallel trend assumption, if from the beginning C was higher than A, which means that the control group has higher income compared to the treated group, even without the program, because of the trend in time, D will be also higher than B. Okay, but now we want to know if the treated group, those who benefit from Forsa, their income improved more with the program. So the gap between B and D is lower because of the Forsa program or not. So we wanted to test the impact of Forsa on the improvement of the income of the beneficiaries. To do this, we can have, if in case that the condition exogenality of treatment is justified, the stronger assumption that, as I told you in the beginning, it consisted of that the treatment is not affected by the unobservable characteristics, that being selected into Forsa program has nothing to do with the unobservable characteristics of the beneficiaries. If this is the case, so all what I have to do is to compare the income of group B of the treated group with the income of the control group. Simply, I will measure the gap between both, and I will see what is the value of this difference. And in this case, I will see the impact of the program. However, as we mentioned, this is not always justified, and in this case, it will be also only called the first difference approach, that you are only doing the difference between the income of two groups, group benefiting from a program and the group is not benefiting from the program. But because this is not the case, and as we said that this strong assumption is not verified because even the selection into the program would be affected by the unobservable characteristics. We have to compare the difference between the income of the treated group before and after the implementation of the program and the income of the control group before and after the implementation of the program. If I return to my example, so the treated group, their income was A and increased to B. The difference for this group who benefited from FORSA, their income improved by the difference between B and A. And the control group, their income increased from C to D. So their income over the years changed by D minus C. So this is the change for the treated group, and this is the change for the control group. The difference between both, the difference for the treated group minus the difference for the control group, give me the impact of this treatment of FORSA program on the income of the beneficiaries. So I can conclude, if it is positive, that those who are benefiting from the program have higher income due to their participation into the program. So again, if the strong assumption was verified, I have only to compare the income of the treated and the control group. However, it is not the case because we know that there is selection bias related to unobservable characteristics. So the only way to overcome this by calculating the difference over time of the income of each group, of the treated group and of the control group, and then compare the difference between both. Okay, and this is why it is called difference in difference approach. And this difference in difference approach assumes that there is a selection bias based on observed characteristics as the PSM method, and also on unobserved characteristics, but only time invariant characteristics. So we will eliminate the selection bias related to these terms. Of course, we know that there are unobservable characteristics that we can change with time, but we cannot control for it as we don't observe it, and as even with time it would change. So we accept to keep it, but again, it is an improvement compared to PSM, and it would allow us to measure the impact of any policy or any training on the outcome variable of interest. So the main idea of the difference in difference method is that it estimates the average program impact as follows. So it calculates what we have two groups, T equal 1 who are the treated, T equals 0 who are not the treated. So the idea is that I will calculate the estimated difference of income for the treated group between period 1 after the implementation of the program and period 0 after before the implementation of the program. So if I will see my table here, it was the B minus A. So this part, this is the difference of income before after the treatment minus the income before the treatment for the treated group, minus the second part is the income of the individuals who are in the control group after the implementation of the program, minus the income of this group before the implementation of the program. So the expected income of group T, the treated ones, at period 1 minus their income at period 0, given their characteristics X that are observed, minus the difference in their expected income of the control group in period 1 after the implementation of the program, minus the income in period 0, given that they are not treated and given that there are given their observable characteristics. Okay, if there is, if we assume that the counterfactual group their income would not change over time for any reason, we can, if we have this condition, in this case, what will change in this equation? Assuming now that I'm telling you that the counterfactual group, there is no reason that their income changed between period 1 after the implementation of the program and between period 0 before the implementation of the program. What would change in this equation?
The second part will be deleted.
Exactly, Anna. The second part will be 0 because in this case, y1c minus y0c is 0. I mean, it is the same income. The income of the control group before the program and after the program is the same. And if this is the case, it will be, or if this assumption is verified, the difference in difference estimator will be only before and after. I have only to compare the income of the treated after. So my income was 10 Egyptian pounds, and after the implementation of the program is 50 Egyptian pounds. So you can see that the income increase, the program increased my income by 40 Egyptian pounds, and it will be easy. However, given the assumptions that we talked about in the beginning, the parallel trend, we expect that this part is not zero, that even the control group, we are assuming that their income would change over time, or our outcome variable of interest would change over time. So given this assumption now that we know that this is not equal to zero and this is not likely to hold in practice, how can we estimate the effect of the program on the outcome variable of interest, let's say the income, using the difference in difference? So now this is the logic or the main idea behind the difference in difference. Now I will show to you in terms of regression, how can we do it? So the first thing you have to do, you will simply regress the outcome variable of interest, which is in our example here is income, which I will call it Y for individual I at period T. Remember that we need to have 2 rounds at least, because we need to compare between 2 periods to control for the unobservable time in varying characteristics. We will have a dummy variable for the treatment status, if the individual is treated or not. We will have a dummy variable for the time, for the period before the implementation of the program or after the implementation of the program. And we will have an interaction variable between both dummies, the treatment dummy and the time dummy. So our regression will be like this. We regress YIT, we have our constant term. We have gamma, the coefficient of the treatment dummy. We have delta, the coefficient of the time dummy, and beta, the coefficient of the interaction between both. And this is our error term verifying all the conditions that we all know about. So T will be 0. This dummy variable will be 0 before the implementation of the program, 1 otherwise. By definition, the dummy variable of treatment in period 0 will always be equal to 0, because in period 0 before the implementation of the program, by definition, no one benefited from the program. And the TI, the dummy of the treatment at period 1, will equal 1 if the individual is treated and 0 otherwise. Okay. So given this regression now, and as we said that the main, if I return here, the main idea of the difference in difference is that we are estimating the average program impact by the difference in the expected outcome of the individuals treated at period 1 minus their expected outcome at period 0, given that they are treated and given their characteristics, minus the difference in the expected income of the individuals who are in the control group in period 1 minus period 0. So now I want to calculate this DD estimator, this expected outcome, difference in outcome for using this equation. So now I would like to ask you to tell me, in case I have an individual I who is not treated, what would be her expected outcome before the treatment if she is not treated? Any suggestion? Any idea?
I think it is not treated, so it will be just the constant term plus the coefficient of the time. If it's not treated.
It's not treated, so you mean that the T capital will be 0 because she is not treated?
Yes, and the interaction as well.
And the interaction as well, okay. But if I wanted this expected outcome before the implementation of the treatment, when the time is 0, so it will be equal
Okay. Just alpha.
exactly, just alpha.
Mhm.
Exactly, Rehan. So she is not treated, so the T capital will be 0 because we agreed that the T capital I1 will equal 1 if the individual is treated and 0 otherwise. So she is not treated, so this will be 0. But I am asking about her expected outcome before the treatment. So before the treatment, the small t, the time dummy, will be 0. This means before the implementation of the program. So in this case, all this term will be equal to 0. The expected value of our error term should be equal to 0 given the hypothesis. So the expected income of an individual who is not benefiting from the program at the period before the implementation of the program will be simply the constant term alpha. Okay. Now, after the treatment, as we have mentioned, the T capital S will be 0, but we'll have the small t equal to 1 because we are in the period after the implementation of the program. So the T time dummy is equal to 1. So the expected value of the income of a non-treated person after the implementation of the program will be alpha plus delta. If I return it again to my table, it is C, which was the income of the control group at period 0. In our equation, given our equation, it will be simply alpha plus beta. Sorry, alpha plus delta. Okay. Now let's calculate the expected outcome of the individual G when she is treated before the implementation of the program. What it would be given this equation? Any idea?
I think it's not change. Still
we
alpha
lose
plus the omega t I1 blah blah.
But I think we'll lose the term with the time factor, the delta and the beta T1.
Exactly. So T capital is 1 because she is treated. But as Noha said, the small t, the time dummy, will be 0 because we are in period 0 before the implementation of the program. So the delta coefficient delta will be multiplied by 0, and also the interaction term will be 0. So in this case, the expected income of the individual G who is treated at the period before the implementation of the treatment will be alpha plus gamma, only the coefficient of the TI. So this is in our table, it is A. If I return to the table, it is table A. It is value A, the income of the treated group who are benefited from the program, but before the implementation of the program. Okay, now let's see what would be the income, the expected income of this individual who is treated, but after the implementation of the program.
Will be alpha plus
period
omega
T
plus beta, all of constant variable alpha plus omega or beta
all of the
and delta.
coefficient. So it will be the sum of all the coefficient alpha plus gamma because she is treated, so T will be equal to 1, plus delta because we are in period T equal 1, so we are in period after the implementation of the program. And given that T capital equal 1 and the time dummy equal 1, it will be also beta. So the expected outcome or the expected income of the individual G who is treated after the implementation of the program is alpha plus gamma plus delta plus beta, which is in our example is B. So now if I ask you to implement the difference in difference method, as we mentioned, that it is simply equal to the expected value, the difference in the expected value of the outcome of individual treated before and after minus the expected value of the income of the control group before and after. Given the coefficients that we calculate, according to you, the impact will be equal to what?
I think when it is treated or not treated, difference in difference. For treated, I think alpha plus omega minus alpha plus omega plus beta plus delta beta.
No, but let me
Then
clarify a point. No, just a point. The difference in difference calculates the effect of specific program on the specific variable. So you take into consideration the beneficiaries, the treated ones, and the non-treated ones. If I return again to the table, the idea of the difference in difference that you wanted to see what would be the income of someone who benefited from the program compared to someone who did not benefit of the program. But given that you have the advantage of having different observations of time, so you will calculate the difference for the treated group of the increasing of their income over time, which is B minus A, minus the difference in the change in the income of the control group, which is related also to the evolution over time. And the difference between both will give you the effect of the program, which will make you say, okay, the treated group have higher income or lower income, it depends on the value of the difference in difference coefficient compared to the control group. So we can conclude that the program increase or decrease their income. So you have to do it for both, the D coefficient.
I think it will be beta.
It will be beta. Okay, so Ganna said it will be beta. Who agree? If you can just raise your hand virtually.
I
And
think
if it's
alpha
not,
and will cancel each other, alpha and gamma, I think.
okay.
So we only left with delta and beta.
So Hala said delta and beta, and Ganna said beta. Who agree with Ganna and who agree with Ganna first? Okay, who agree with Hala? Those who did not agree with anyone, you didn't agree with any, or you just it's not clear, or you, I mean, what the silence means.
I think it would be beta. I agree with that.
Beta. So Noha said as Ganna beta. Okay, so let me say it again to make sure it is clear. Assume that Ganna and I, we both have different income, and my income is higher than Ganna's income. Okay, this was the case last year. This year, we can expect that my income will remain higher than Ganna's income because there is a trend over time. So in any case, my income will be higher than her income. My income may be increased by 10% and her income increased by 5%. Okay? Now we wanted to know if given, I mean, between the last year and today, I participated in a training program. So we don't know, we are not sure if the 10% increase in my income is due to just the fact of the evolution over time, given that already my income was higher than her, or because I was already participating of this program. So this program managed to increase my income by this effect. So my income increased by 10%. We don't know if this increase is due to the program or to the evolution of time only. And her income increased by 5% over the time. The difference in difference approach tell you if you wanted to compare between, or if you wanted to measure the impact of this program on Russia's income compared to Ghana income, you need to just make the difference. So the change in my income, which in this example will be alpha plus gamma equal to 10%. The difference between both alpha plus, I mean, this is my income before and this is my income after. The difference between both alpha plus gamma, or it will be the opposite, alpha plus gamma plus delta plus beta minus alpha plus gamma. Okay, this give me, so here, the difference equal the income after the implementation of the program this year, alpha plus gamma plus delta plus beta minus my income last year, which is alpha plus gamma. This gives me what?
Delta plus beta.
Exactly, delta plus beta. So this is my 10%. The increase in my income between last year and today is delta plus beta. Ghana did not participate in the program. The change in her income is related to the evolution in time, because with time we are supposed to have higher income. So her income last year was the difference. This is the difference for the treated for Russia, and this is the difference for the control group for Ghana. It will be equal to her income this year, which is alpha plus delta, okay, minus her income last year, which is alpha. This gives us what value? No,
Delta.
Hala, you did not win yet. Wait, you did not win yet. Alpha plus delta minus alpha. It gives us what?
Delta.
Delta.
Just the delta.
Exactly. So delta equal the 5%. So this is the change in Ghana income, which is 5%, and this is the change in my income over the years, which is 10%. Now my question was, I want to know if the increase that happened in my income, this 10%, is simply due to the time, or because I benefited from specific program during this period, so this will provide me with the impact of this program or my income. To know this difference in difference approach, given what the equation I told you, it will be simply the delta of the treated, the change that happens in my income minus the change that happens in Ghana's income. So it gives us the change that happens in my income is delta plus beta minus the change that happens in Ghana's income, which is delta, equal what?
Beta.
Beta. So Ghana wins. The difference in difference coefficient that shows me the impact of any specific program or policy on the outcome variable of interest. In the case of difference in difference, it's simply the coefficient of the interaction term. Why? Because as we see, if we calculate the expected outcome of individual who is not treated after and before the implementation of the program, and we calculate the difference, then we use the income of someone who is treated, and we calculate its expected income before and after the implementation of the program, and we calculate the difference. The difference in this difference give you the coefficient of the interaction term. So simply, this means that the difference in difference method so the difference in difference estimator is simply we want to apply this equation given our regression. It gives me the coefficient beta. This value, if it is positive, this means that the implemented program or training or policy has a positive impact on the outcome variable of interest. If it is negative, and of course it should be, it should be significant. If it's not significant, this means that we don't have significant difference between the treated and the control group. And if it is negative and significant, this means that the program has a significant impact on the outcome variable of interest. And this is verified under the weaker condition or the identification assumption that we mentioned, that we assume that the selection bias is based on the observable characteristics and the unobservable characteristics that are time invariant. And this method, given that we compare, we subtract, we make the change between two periods in time, if the unobservable characteristics are invariant, it will cancel each other in the calculation of the change over time. So in this case, we know that it's not the unobservable characteristics of the individuals that are invariant in time that are affecting the selection bias, and they are not the observed characteristics, also because we are controlling for these observable characteristics. So the effect of the treatment on the treated, that what we wanted to calculate since yesterday, is simply the coefficient of beta. And even if we control for x's, and if we wanted to if we control for instance age, education, anything, all these observable characteristics, it will remain beta. The coefficient of the interaction term between the treatment dummy and the time dummy is the one explaining the effect of any specific program over individuals while controlling the unobservable, the selection bias related to the unobservable characteristics and the observable characteristics. Is it clear? Any question?
That question,
Yes.
Dr. Rosha. I'm only confused for the difference. Why from the beginning do we have a difference in the income or in the outcome in general between treated and control group? Because what I have in mind, if we want to compare between two groups, if the program will have an effect or not, like the PSM, I have the PSM in mind. We should have from the beginning like similar characteristics, not similar outcome, I know, but why do we have from the beginning this shift in the graph you show us in the beginning between the parallel shift between the control and the treated? Should we have always this difference in the outcome before the program between treated and control for the different, or maybe they have same level of outcome in the beginning, and then I'll see if the program will make an effect or not.
In fact, the main idea is that usually when you want to implement a policy or a program, and this, I mean, this is related to the selection. So, for instance, I will choose those who have lower income to implement. If I will take the example of Forza program, so I am already working with the individuals who are benefiting from takaful, who are already poor and have low income. It's possible that you can start from the same point in time. It's
Okay.
possible. I mean, you have the two possibilities. If I return to the graph, it's possible that you will have the same point in time, and you know that
And so,
reason of time, the evolution over time, the income of both groups will increase. But if the increase of the treated is higher, you want to know that this is because of their characteristics or because of the program. So this, as you said, as a PSM, you start from an initial point where they all have the same income, but you decide to select some individuals, give them gives them this training, and you find that everyone in the sample from the beginning, even if those who did not benefit from the program, their income increase over time. So now you want to know if this increase is related to the time or related to the income. Okay, this is a possibility. So
okay, but all of them are within the range of the income that are suitable to be selected in the program, but some are treated and some are not with different level of income. That's
exactly.
right?
Yes,
Okay.
exactly. And
Okay.
this is the case.
Thank you.
Even without the program, we know that with time things will change and there will be an increase. But now you want to know if this increase is related to the income, to the program or not. But even if, I mean, for instance, the poor, yes, there are poor that are just below the poverty line and those who are very far from the poverty line. So they are all considered as poor. Some of them will benefit from the program. Now I am poor and you are poor, but my income is still higher than yours. So maybe I have the capabilities and the skills that you don't have, and they are unobserved. So with time, both our income would increase, but I am the only one who benefited from the program. You want now to know this increase in our income is related to my characteristics that already made me in a better situation than you, or because I benefited from this program. And maybe I benefit from this program from the beginning because I have characteristics that are different from you that no one can observe.
Okay, thank you so much. Thank you. It's very clear. Thank you.
Other question? Okay. Here in the example I gave, I did not include the X. However, it will be very simple to include, as I mentioned, other covariates that allow us to include observable characteristics like, for instance, age, education, gender, geographical location, whoever. And in any case, the ATT or the average treatment for treated will be the coefficient beta. However, still, if you believe that, for instance, maybe this program, as we will see in the STATA example I will give you today, it's possible that it is on microcredit that it will make a difference if the receiver or the beneficiary of the microcredit is a male or a female. So if I believe that the gender factor will affect the impact of this program on individuals, So I can interact the exogenous variable I am interested in, which is in this case will be the gender. I can to interact it with the treatment variable and with the interaction variable. And this will provide me with coefficients that, or the B, the ATT, I will have two values depending on the variable I include in my interaction. I can, for instance, maybe believe that it is the education level that would make a difference of this training. So if I have 10 years of education and I got this training, it's not like if I have 12 or 13 years of education when I receive this training. So you still can, and this is interesting because it allows you to, if you have heterogeneous groups and if you believe that some observable characteristics, some X's can affect the impact of your training, you can interact this variable or this factor that you believe it would have a heterogeneous effect on your outcome. You interact it with the T, the treatment and the time variable to see this heterogeneous effect. As I said in the beginning, usually difference in difference is used with panel data because it takes advantage of having data over time, so you can correct or delete the selection bias of the unobservable characteristics based on having two rounds. So we can use it, for instance, for ELMP with the ELMPS. I think this is the only panel I know in our region because even the DHS is not a panel. But sometimes you can still benefit of the difference in difference method because it allows you to control for the unobservable characteristics that are not varying over time and use it on cross-sectional data. Here, how you can use it, you will use it instead of having two periods on time, you need to have two groups, we can say two villages, two cities, where one city you assume, or one village or one group, you know that it's not expected to be affected by any means by the treatment. So this will be our period 0. So you remember you have at T0, no one is affected by the program because simply the program was not implemented at T0. Sorry, let me write it as the equation. So at period T0, you know that no one is benefiting from the program at all because simply the program was not implemented. And at period T1, you know that some individuals will be treated. I will call them I individuals will be treated, and other individuals, I will call them G, are not treated. Okay, so this is the main idea of difference in difference, that you have 2 points in time. One, no one is treated. For everyone T I equal 0, no one here is benefiting at all because there is no program. Then there is program, and this is the period T1. So you benefit from this change over time to control for the observable characteristics, for the unobservable characteristics. Now, if you wanted to implement it to cross-sectional data, you need to find a group of persons like in period T equals 0, that no way they will be benefiting from the program. So assume you have two cities, city A and city B. So in city A, you need to make sure that everyone in the city, no one is expected to benefit from the program at all. So it is the same idea at being in period 0. You cannot have anyone benefiting from the program as if the program was not implemented. And you have city B, where you have some individuals who did not benefit from the program, like those ones who is T treatment equals 0, and you have others who will be benefiting from the program. So we'll be treating the cities as the time, and you will be treating the individuals within city B, as benefiting from the time, benefit from the program. And here, of course, you need to match to make sure that they have the same characteristics. But by experience, it's rarely to find someone using difference in difference on cross-sectional because it is very difficult to I mean, even if I will take the example of تكافل or many cash transfer programs that are implemented in specific governorates or specific cities. So the government choose a specific area and say, okay, this area or this village or this governorate will benefit from this program and the others not. So now you have your village A and village B, and within village B, you can the government can select who will benefit from the program and who will not benefit from the program. But it's very difficult to make sure that, I mean, there is no leakage or someone from city A will come to city B to benefit. However, still you can use it if this is the only way to use this methodology to control for the unobservable characteristics. So again, as I mentioned here, in this case, if you want to use difference in difference on cross-sectional data, you need to use to find a village with the program and the village without the program. And then you need to find targeted and non-targeted household or individuals like we see in the beginning of the sim. And in this case, your difference in difference coefficient or your average treatment effect would be the targeted and the non-targeted individuals, so your treatment, the difference, the change between them, minus the change over the same difference in non-program village. So in the village where, which is in our figure was B, in village B, you will calculate the difference between the green individuals and the red individuals, those who benefited and those who did not benefit. And in village A, you will see the same difference between those who can benefit if there was a program and those who did not benefit, and then you calculate the difference between them. Okay? And any question, any comment? It will be clearer. If this is not clear, we'll see the example with STATA. But the main idea is that you have to recreate the idea of time, but in terms of village, to make sure that you are differentiating between both individuals who are living in this governorate or the village where it's supposed to implement the program and benefiting of the program, and those who were not benefiting from the program. Any question, comment? Okay, before to go to the STATA application, because today's STATA application is longer a little bit than yesterday. Let me just provide you with sorry, before going to STATA, I mentioned yesterday that we can implement a difference in difference with the PSM. And the advantage of using both methods that you are sure that you are controlling for all the observable characteristics, and in addition of controlling of the time in varying unobservable characteristics. And here what will you do? That you will treat the sample as the PSM. So you will doing a match based on the pre-treatment characteristics using wide data, and I will talk in a minute about what I mean by wide data. You will calculate the p-score for everyone. So you will apply the PSM method based on the characteristics that you know, the observable characteristics that you know that they can affect the selection into the program, and in the same time your outcome variable. You will calculate the p-score for everyone, which is the probability of being selected into the program. Then you will apply the difference in difference regression. However, you will use as a weight, like we saw yesterday, the p-score. So this would allow you to control for the probability of selection into the program, which is advantageous because you will take into consideration or get the benefit of both methods. Yes, sure, Noha. You want to add in the previous slide?
Oh,
Yes.
yes. Yes, in the previous slide of the cross-section difference. Okay. So what I understood is that we will have the difference in village B between the treated and the non-treated, and then we'll have the difference in village A between the both untreated, and then we'll get the difference between the difference between the two differences, right?
Yes. Yes.
Okay, so in village B, it's easy to get the difference because we have some treated and non-treated, so we'll get the difference here. But I'm not sure I understand how we'll get the difference, yani how we'll select the two groups that we're getting the difference between in the non-program villages, since they will all be the same. Yani what will be subtracted from what?
It would be, again, you will have to specify the individuals as, I mean, matching them, those who can be benefiting from the program if they were in the village where the program is implemented.
So we'll have like pre-specification in village A that determines who will be يعني, more likely to be treated.
Yes.
And we'll consider them the first group, and the others will be the second group, and get the difference between them.
Yes, exactly.
Okay. Thank you.
And this is why I said it is, I mean, it is less intuitive than in terms of time, because of term of time is more intuitive, but I mean, this is a possibility that you can use it if you have cross section and you want to use the difference in difference.
Okay, thank you.
And you will, I think it will be also clearer when you will see the STATA application of it. Other question? Okay, so again, if I wanted to get benefit of both methodologies, we can simply calculate the p-score for the whole sample based on the pre-treatment characteristics that we know that affected the selection into the program and the outcome variable of interest. And in this case, you will use the p-score as a weight. You will not use I mean, you will use it as weight as we calculated yesterday, the inverse propensity weight. And if you have already a sampling weight in your data, you can multiply both. So this would allow you, I mean, when you run your regression, your coefficient or your variance will be corrected by this weight, and this means that you are controlling for the observable characteristics using both methodologies, the PSM and the diff-in-diff. A couple of comments before applying on STATA, which I think you studied with Dr. Shahir in the last week, that when you have a panel data, you have several individuals observed over time. So we have for each variable we have the index I for individual and T over time, and the idea, and this what is related to our variables, to our methodology today, that some variables are not varying over time and others are varying over time. So the variables that are not varying over time, like for instance, sex is not supposed to vary over time. If you find that it changed over time, this means that it's an error. However, for variables as age, for instance, if you find that it does not change over time, here also an error, because we're supposed to grow with time. Employment status, it can change and it can maybe not change. It really depends, but is a more, I mean, I have been working in the university for 15 years. Yes, if I maybe take my position, it changed, but it's possible that I will be staying in the same place for a long time. And the income also is supposed to change over time. So this is really important to consider, because the variables that are not changing over time, these are the variables that will be eliminated with the difference in difference. And of course, also what we cannot observe, given that we will use 2 points in time, we assume that we are eliminating any unobservable characteristics that are constant in time. But we will allow us to see or to measure the change that happens in any variable that it is evolving over time, whatever this evolution is. I mean, employment status, I can change my employment. I was wage worker and I become self-employed, or the income, it may increase, but if I got retired, so it will decrease. In this case, it depends in which sense the evolution is of your variable. However, you need to make sure sorry. That your data is panel, you have the observations of the individuals over 2 points in time, and to make sure what is varying over time and what is not varying. I don't know if have you seen this with Dr. Shahir, that you have long data and wide data?
No.
Okay, so panel data come in 2 forms. What we call long data, which is for each individual, you will find 2 lines for the period 0 and the period 1. And it's possible also that it come in wide data, where you have for each individual 1 line But for each variable which is changing over time, you will find two columns. Let me show you. So here, this is a long data. You see that for the individual ID, here we have 3 points in time, 80, 81, and 82. You see that for individual one, we have 3 lines for each individual because we have 3 periods of time. Okay, you have the variable year. So always in panel data, to be able to use difference in difference, you need to have these two variables: the identifier of the individual or of the household or of your firm, and the identifier for the year. So you have to have both. Then you have variables like sex, for instance, which is not supposed to change over time. So you will see the same variable, the same value is repeated for the individual, given that it does not change. While for income, which is a variable that is supposed to change over time, you see that for the same individual, you have three values of the income. This form of data is long data, and this is important to consider, as I will show you when we start working with STATA, that if you count the number of observations, for instance, if I say that I have 90 observations, this means that I have 90 lines, but it is possible that I have only 45 individuals. Because if it's panel data and it's in long form, this means, and I have two rounds or 2 surveys or 2 points in time, let's say to 2024 and 2025. So you will have, if you have it in long form, you will have for each individual 2 lines. So you will have 90 lines, 90 observations, but you have 45 individual or 45 household, and this we see. You have another form of the panel data, and I will show you how you can change between both. It is the wide data. The wide data, it has this form. So for each observation, for each individual, you have only one line, one observation. You have the variable that is not changing over time, does not have any suffix or any indicator of the year. And then you have, like the variable in our case, the income, you will have a change in the, you will have the change in the suffix of the variable to reflect the year or the round of the surveys or whatever, as you also will see. You can call it, if I will focus on the change between 80 and 82, because the program was implemented in 81, so 80 will be my year 0 and 82 will be my year 1. So you need to know that panel data can come in both forms. Usually we will need to use the wide form to be able to implement the diff and diff, but we can change between both using the command which is called reshape. Reshape allows you to reshape, as it says, change the form of the STATA data between long and between wide form. But I mean, yes, you know, to get to know the data set, and one of the also useful commands when you have panel data is a duplicate report, because it would, I mean, the duplicate report will be based on the unique individuals, so it will take into consideration the identifier of the individual or of the household, and it would allow you to know if there is duplication. I mean, if you don't know if it is wide or long, with the duplicated report, it can shows you that there is duplication, which means that the same identifier will be repeated twice. Of course, in case like if you have a cross-section data and you use the duplicate report, it's also important if you have a mistake, for instance, and the individual is repeated twice, and this is not supposed to be the case. So duplicate report is important to show you if there is duplication. If it is a panel data in long form, it is expected to see a duplication in the identifier of the individual, because we know that the individual will be repeated over several lines. But if you don't have a panel data and you are not supposed to have 2 individuals with the same identifiers, it will allow you also to eliminate any duplication. But I will show you in practice. Any question, comments? Okay, so let me go to STATA. I will show you quickly the data, and then we'll break for 10 minutes, and I will send you the data set as yesterday. So here's the data set. Okay, where is it to find? Okay. So here is a data set for today. Again, as I mentioned to you yesterday, I like to write a lot of comments to it's kind of like a journal, so I know what we're doing. If I wanted to work with Shahir, for instance, so we can change things for you when I send you the do file. Again, this do file is based on an original data file by Dr. Rogi Asad and Dr. Caroline Crafts, and we make some change. And they used materials from this paper by Kandekar, Kulwal, and Samad. So this data is from the Bangladesh household survey, where there are two rounds, a round of 91, 92, which will be the period 0 in our case, and the round of 98, 99, which will be the period 1 in our case. Okay, this survey was conducted by the Bangladesh Institute of Development Studies and the World Bank, and we have information at the individual level, household level, and the community level. In our example, we have 826 households were interviewed in both years, and you will see, I will show you the data. It is long. We have the year and the individuals, where individuals are repeated. The Bangladesh is divided into what they call sanas or sub-districts, let's say like villages. We have 29 villages, 24. Our treatment program is a credit program, micro-credit program. But there is micro-credit program only for men, and there is micro-credit program only for women. And what we wanted to measure is we wanted to measure the impact of these microcredit programs on several outcomes variables. I will give you the example of today. The outcome variable of interest is total expenditure per capita, which like the income. In the implementation of the program, you have 24 villages or sanas, which correspond to around 1,540 households who can access these credit programs, and you have 5 villages who had not been targeted by the program. So if I will return to the question of Noha, so here you have the Noha, the 24 sanas are like the time T equal 1, because this is the implementation of the program. You will have beneficiaries and non-beneficiaries, and you have 5 villages that can be considered as your time 0, where no one is benefiting of all of it. Okay. As I mentioned, we have mainly only program and women only programs, and the eligibility criteria. So here we know, again, if I return to your question, we know that for anyone to be eligible in the villages where the program is implemented, they need to have less than 1/2 acre of land owned. So they need to have, almost no land. So I can implement this criteria in the villages where the program was not targeted, because I know the cutoff or the selection criteria. I already opened the data set, and as usual, I save it under another name. So just let me show you how it looks like. This here. Okay, your file is already open. So here is the data set. So this is the long data. The shape of the data, of this panel data is long, because you see that you have the household identifier, the year, the village ID, the SANA ID, the age head, the sex head, the education head. So here you have, for each household, you have 2 lines. Okay, because you have year 0, as I told you, it is the year 98, 91, 92, and the year 1, which is the year 98, 99. So here is long, because for each individual, for each household, you have 2 lines. You see variables at the village. Of course, we can migrate. It's possible. I'm living in Cairo in 2024. Maybe I will move to Alexandria in 2025. So it's possible that the village changed, but here it did not change. The age of the head, of course, it will change over time, because we are supposed to grow old. For the sex of the head, it's supposed not to change. For the education of the head, it depends. So you see, and this is really interesting example. For instance, for this household, the education of the head did not change between the 2 years. If we wanted to know what is this education level, So it is years, is number of years of education. So if you see here, this first individual, this first household, the head has no education and did not learn any extra or any more between 2 years. But for the second household, he was or she was, I mean, 500, she has five or he has 5 years of education in 1992, but then he had additional year of education. So he or she learn more. This, for instance, is surprising. This suppose here there is a mistake for many reasons. First, they get younger in time, which is not normal that we get younger in time. They change the head. Okay, the change of the sex of the head is possible that it was a man and then he died, so the wife. This is a possible case that he was a man who is 54 years old in 91 and he died. So his wife, who became 52 years old and she is female, became the head. So here we can understand, and of course the education is different. Here it can be the case. So you need to make sure if this the change that happened, that she became widowed, so now she is the head. But if it is an individual, not household, this would be weird that the age declined, that the sex changed, and the education declined as well. But here, as I told you, it's possible that the household structure changed given the household age. And I mean, I will not go through the whole sample. I just want to show you that this is how it looks like the long data, panel data in this form. And usually it came in this form. I don't know why, but I believe it's easier for data entry. Okay. As we mentioned, one of the useful commands is duplicate report. So duplicate report, you specify the variable that you want to do the duplication based on it, and it will tell you if there is a duplication or not. And again, it's useful if I have the cross-sectional data and I know that it is at the individual levels. I want to make sure that no individual is repeated twice by mistake. So duplicate report is useful for this. So here I ask STATA to provide me with a duplication report based on the household identifier. So the results, this a nice table, it told me that you have 1652 observations that in total. So in total we have 1652 lines. You have 826 household repeated twice. In other words, if I do command count for you the number of lines in the data set. So I have 1652 lines, which is the number of observations. And if I said code book number of households, I have 826 unique identifiers. So I know now that I have 826 household observed twice. If I do the same thing, duplicate report with NH and year, so here I am asking STATA not only to consider the household number, but also the year of the household. Here you see that you don't have any surplus. If you take into consideration the identifier of the individual of the household and the identifier of the year, here you don't have a repetition. So I know now that I have a long panel data. Okay, is it clear, or I'm going too fast, or okay, I will assume that everything is fine. As I told you, I mean, yesterday in the data we use, I didn't use the weight. Here I have already a sampling weight in the data set. So, sorry again. And the advantage of the sampling weights, whenever you are doing any analysis with surveys, when you use the weights, it allows you to generalize your results at the country level. If I use weights here, I can generalize my results at Bangladesh level and not only given my sample. But I will show you, if we will use the PSM with the different diff, how we can use this weights with the weight of the PSM or of the P-score. As I told you, we have programs that are male specific only for men, and we have other micro programs that mainly for women. Here I will show you for the program for men. If we run, we have just to tabulate. Oh no, sorry. Let me do this before. So here, this variable DMMFD shows you the number of households who confirm that they have male participants in the male credit program. So you can see that we have around 12% of the sample who has who benefit from the microcredit program for men. If we do the same thing for women, and here I am taking into consideration the weight, we have around 29% have microcredit or participate in the microcredit program for women. So you already see that women programs are more used, or there are more beneficiaries of the female programs compared to male programs. For the same household, we can have households who have female benefiting from the program of for female, and male benefiting from the program of male. So we can have interaction between both. And here, as you can see, we have, for instance, let me do it froze. So among all the household who had a male participant in the program, okay, the number was around 196 household, 38% of them have a female beneficiary as well. Okay, so this means that having a male benefiting from the program would not prevent having a male benefiting from the male microcredit program. They can benefit of both programs, but we want to see the impact of each program apart on the total expenditure of the household. Of course, as I said, we can use different outcome variables of interest. I can measure the impact on, I don't know, the health, the education. But here we decide to measure the impact on the total per capita expenditure per year for the individuals. And in Bangladesh, the units is taka, which is around, 40 taka, as this period was around 1 USD. So now I will create a total expenditure variable. I will call it a total expenditure 0. It will be equal total expenditure 0. So the total expenditure if I am in the year 0. I wanted to create a new variable for the expenditure in the year 1991, which is my base year, which is the 0 year. Okay, so we create this. Let me show you. Okay. So you see in the data set now we have a new variable called expenditure total 0 equal the total expenditure for the household in the original years. Now I will create a new variable. Here I'm just playing with the commands to show you all the possible commands. With the reshape, with the reshape command, it will be easier to change it. But I want to show you how you can do it. If I show you the data set, how it looks like now with what so here you have this household identifier, the year, you have the total expenditure for each year, and here I created this new variable called expenditure total 0 equals the value of the total expenditure of the household if we are in year 0 and missing value otherwise, because I'm not creating any value. I'm telling STATA if it is the year 1, don't put anything. Now I will create a new variable. I will call it I will call it expenditure total 91. It will be equal the maximum value of the variable of expenditure total 0 by household identifier. Let me run it and then show you how it will look like. Sorry. So here you see we have the household identifier, the year, total expenditure 0, and here expenditure 91, where I just replicated the value in, I mean, instead of having missing for the year 98, I have the same value of the 91. I will show you why I'm doing this, then we will go into a break. Okay, now I can keep only if the year equal 1, which is the year 98. So if I keep year equal 1, and I will show you now. So now I have the total expenditure per capita, sorry, the total expenditure without any other indices is the value of the total expenditure in year 1. And here I have the total expenditure in year 91. So I created two columns with, instead of having the total expenditure over 2 lines, I created over 2 columns. Again, we can do with reshape. I will show it to you at the end, but here I wanted to show you different ways because sometimes you need other variables to be here, and the reshape sometimes you have to drop variables if they are not changing over time, as we'll see. So now I will rename the total expenditure in general by total expenditure 98, and I can just show you, or we wanted to see if there is an average, if there is a change in the total expenditure between the two households. Let me here. Sorry. And again. Okay, so here you can see that the total expenditure for the year 91, the average is around 899. There is something wrong. Yes, 899. Sorry, 822. This is the week 12. It is 45 taka on average, while it became 5,887 taka per for the year 98. So here this is the trend that you can see that on average the value of the total expenditure increased over time, which means that we expect that every household in the survey, their income increased between 92 and 98, as we saw in the trend. Because the total expenditure, we have outliers between the minimum and the maximum. You have very high values and very low values. This is why we will use the log expenditure instead of having the value of the total expenditure to take rid of this any fluctuations or any outliers. Okay. The first thing you can do, why expenditure not wage? This is a good question, Hala, and it can have several answers. So usually in the household surveys, you will have total expenditure. Or let me say it in the other way. In general, in developing countries, the household surveys include data on income. So income, this includes wage, profit, any transfers, and data on expenditure. But in developing countries, we use, I mean, by we, I mean researchers, and in the literature, we use expenditure because first, it's easy when you ask someone how much you spend over food, they will reply you. But if you ask me how much I'm gaining, I may not reply you. So you will have a lot of missing in the wage and in the income. Or I will tell you I am gaining 10 Egyptian pound while I am gaining 1,000 Egyptian pounds. So usually the literature on developing countries, we use expenditure, not income, not wages, because it is better reflecting the income level of the individuals. and you don't have missings. It's very, I mean, again, if I ask you how much did you spend on food last month, you would tell me I spent, I don't know, 50 Egyptian pounds on bread, 1,000 Egyptian pounds on meat and fish, 500 on vegetables. So I can calculate your total expenditure. But if I told you how much you gain, you will not reply at all, or you will reply underestimating your wage or your income. Yes, it's about culture, and this is why I'm saying in developing countries, data on income and wages are more available and more accurate in developed countries. This is why they usually use income, but in developing countries, we always use expenditure, even for calculating inequality, poverty, and it is commonly used in the known in the literature that is more accurate to use expenditure. And so this one answer, general answer on this. The other answer is that it really depends on the program. For instance, here I am using the total expenditure, but it is possible that I want to know if this microcredit is spent, I want to know how it is spent. Is it spent on food expenditure, for instance? So the individuals are getting this credit to buy more food, or I want to test it on the impact on expenditure on education, for instance. One of the assessments that was conducted in Egypt on Takaful program, they wanted to measure the impact of this cash transfer on expenditure on education. So here I need to use expenditure because this, what is my outcome variable of interest is I want to know if individuals will benefit from this cash transfer on spending more on education or not. Okay, so one simple thing to measure if there is a difference or what is the difference in the expenditure between individuals who are benefiting from the microcredits and those who are not benefiting from the microcredit is to simply compare the average of the total expenditure per capita between the two groups. So what we can do that I can create the difference between the total expenditure per capita between 98 and 91. So I will create this variable and I call it LX tot 98, 91. Okay. And then by the variable of treatment, our dummy variable of treatment, I will calculate the average. So here you have those household who has no male benefiting from the credit and those household who have male benefiting from the credit. So simply by seeing the average, you see that those who don't have male benefiting from the credit, their average total expenditure is higher compared to those who benefit from the credit, as if this microcredit program for male is not really increasing the income of the household. If I want to know if the difference is significant or not, let's come here and just make a simple t-test with the null hypothesis that there is no difference between the two means, the mean of the expenditure in 98 and the mean of expenditure in 91, and let's run it. So you see that you have no significant difference between the two average or the two consumption, those who are benefiting and those who are not benefiting. So we can conclude that there is no significant difference between the household who benefit from the male credit and the households who do not benefit from the male credit. Would the female credit have significant impact or not? And here I am doing just a simple comparison, t-test to compare between the average expenditure of those benefiting and those who are not benefiting. If women have a difference or not of their microcredits, what would be the results when we use a diff and diff approach? We will know this in 10 minutes after the break. See you in. Hello back, welcome back. Okay, so as I said, we simply tried the comparison, I mean, a t-test, and this is just only to get familiar with the data to see if on average, simply before implementing the diff and diff would make a difference. There is a difference between the per capita expenditure of the household benefiting from the microcredit specific for male versus those who are not benefiting from the program. I will do the same thing for the households who have female benefiting from the program to compare also again the simple the average consumption, the average total per capita expenditure between both. I will run both. Let me be here. Okay. So here, by doing the summarize command, we can see that the household who don't have female beneficiary from the microcredit have on average per capita expenditure 0.15, while those who have female benefiting from the program, they have on average per capita expenditure 0.24, which means that without comparing, without doing the significance test, we can see that those benefiting from the program have higher expenditure. Now let's see if this difference is significant or not when I run the test with the null hypothesis that there are different from each other, that the difference equal to 0. We see that we can conclude that yes, those who benefit from the program have higher total per capita expenditure compared to the household who do not have female benefiting from the program. So simply by comparing the average value and the significance of the difference, we can say that, okay, the programs targeting women have positive significant effect on the consumption of the household, on the expenditure of the household, which is not the case for the programs targeting men. Okay, now let's go deeper by using any of our methods. So here I am showing you different ways. I mean, we can run a simple regression by including a dummy variable equal 1 if the individuals are benefiting from the program, 0 if they're not benefiting from the program, like here. So these are different methods before starting the diff. So here I am regressing the difference in the total expenditure per capita between the 2 years on the dummy variable equal 1 if we have a male benefiting from the program, 0 otherwise. Let's see the results. Okay, yes, I have to set the data first. When you have survey data and you have the sampling weight, you can use the command survey set to make sure that all your regression take into consideration and all your commands take into consideration the weight of the survey, and this is survey data. So here it is simple regression. I just regress the difference, the change that happens in the total expenditure per capita between the 2 years on a dummy variable when men are benefiting from the program or not. And here you can see by the sample regression, like the comparison of the average expenditure between the two groups is not significant. If we do the same thing for the female, you see that it is significant, though it is at 10%, but still we can say that the programs targeting women have a positive significant effect on the total expenditure of the household, which means that it's better to target women. Okay, now let's use our diff models, because all this, I mean, comparing only with the t-test, the significance of the difference between the two total expenditure per capita of the two groups, or running a simple regression, does not take into consideration the fact that there is endogeneity, as was discussed, as was asked by Dr. Iham yesterday. It does not take into account that this microcredit program is not random, and there is a selection bias based on observable and non-observable characteristics. So now we will use the difference in difference methodology to see if this has really a significant effect on the total expenditure of the households or not. If I return back to the slides, simply we need to estimate this regression, and our diff coefficient, or our average treatment for treated, is the coefficient of the interaction of the interaction between the time dummy and the year dummy. So I need to create the time dummy. I have the treatment dummy, which is the variable equal 1 if we have a male benefiting from the microcredit, 0 otherwise. Now I have to do to create the time dummy and estimate this regression, and beta hat will be our variable of interest, and we can include regressors as we discussed. Let's return to STATA. So here, I will use the original data again. Okay. I will create the log of the total expenditure per capita. Okay. And I wanted to create the dummy variable for the time. And I wanted to create as well the interaction so the interaction variable between the dummy variable for the treatment and the dummy variable for the time. Okay, so again, we have the variable DMMFD, which is the dummy variable equal 1 if the household has a male benefiting from the microcredit, 0 otherwise. Now we want to create a dummy for the year equal 1 if the individual, if this is the year 98, 0 otherwise. And we wanted to create an interaction between these two dummies. So here I am creating all these variables. So if I look here, now I have the log of the total expenditure. I have a dummy for let me show it to you. So here I have a dummy for the treatment equal 1 if the household have benefited from the male microcredit, 0 otherwise. We have a dummy for the year 98, and we have a dummy for the interaction between both, having a male microcredit, which is a treatment dummy, and the year dummy, which is a T small. And this is a variable that we will use for the in the regression to get the beta, which is our coefficient of interest, our diff and diff variable. Okay, we'll do the same thing for female because we wanted to compare both. And now let's start with a simple, not simple, with a regression where we will include only, so I will estimate exactly this equation. I will not include the regressors, the other observable variables. I will only include the treatment, the interaction, and the year dummy. And let's see what we will get. So regress, leg of expenditure total per capita, year, and here the dummy year. And here, if you noticed, I am using the long version of the panel data. I'm not using the wide version. Here, I'm not computing the difference as I did in the previous example, that I calculate the change between the two. I have to do it wide and compare the change between both variables, and then regress the change on the dummy variable. Here I am using the sample in its long form, where each household has 2 lines or 2 observations. But I will include the time dummy and the year dummy. And I will regress the log of total expenditure on these variables, and let's see what we get. So this regression, we have all the results as usual, and let's see what we can conclude regarding our program. Can we conclude from this program that having a male microcredit, having someone in the household benefiting from the male microcredit, increase the expenditure per capita of this household or not? Anyone would be willing to share her or his thought on this?
I think the coefficient here is non-significant. It's 0. Sorry, yes, the p-value is 0.6, so there is no effect.
Exactly, Dr. Rehan. So here the variable, sorry, this variable This coefficient
Yes.
is our beta.
Yes.
And as Dr. Iham mentioned, this variable has the p-value is 0.633, which means it's not significant. So we can conclude that this microcredit program has no significant effect on the total household expenditure per capita in Bangladesh. If we look at the other variables, we can see that for the year, it has a positive significant effect, which means that it is expected, and we agree that the expenditure per capita of the household in 98 is higher than the expenditure per capita of the household in 91. So our increase that we saw in the figure, that it is parallel and it is increasing over time, this is significant. However, having a male individual benefiting from the microcredit is not significant. And mainly, the most important coefficient, our beta, which is the diff coefficient, shows us that there is no significant difference in the total expenditure per consumption of the household who are benefiting from the program for male, and those who are not benefiting from the program of the male of this program, the household, the other households. Let's see what would be the case for women. I will do the same thing. So we created a dummy variable for the year, for the program, and an interaction one, and I will regress it. And I have here the results. Anyone would like to share with us their thinking? Hello, anyone?
Yes, I can reply. If no
Yes,
one,
sure.
yes. It's now significant. So the program had an effect for women, not for men. The beta, it's with the p-value of 0.014. So it's significant.
Exactly. So so the programs who are targeting women have a significant effect on the expenditure per capita of the household, because our beta coefficient, the variable, the coefficient of the interaction between the year dummy and the time dummy and the treatment dummy is significant and positive, which means that households who have female benefiting from the program have higher expenditure per capita compared to the households who have no not benefiting from the program. If I return to the, okay, I cannot return doing this. If I return to the graph, so gamma is a coefficient of the treatment, delta is a coefficient of the year. So here in STATA, this one is delta, and delta is significant positive, which means that having if increasing over time would increase if I compare the expenditure per capita in 98 is higher compared to the expenditure per capita in 92, having a female benefited from the credit has a significant negative effect on the program, which means that the household who benefit from the program have lower consumption compared to the household who are not benefiting of the program, without taking into account the time. But the interaction of both time and the treatment shows us that this program is positive for the household expenditure. And if I am a policymaker in Bangladesh and I saw these results, what I should do, I should stop the microcredit for male because it's not significant. It's not really affecting the household expenditure. However, maybe I need to increase or expand the program targeting female because it has a positive effect, positive significant effect. Here, we are not taking into account the other observable characteristics. We can now add other observable characteristics like the age, education, sex of the head. We can also include the household land, because as I mentioned in the beginning, the criteria of selection into this program based on the area of the land that the household has. We can have some information regarding the village, if the village have access to the road or not, or it is in remote area with no access to the road. and the proportion of irrigated land in the village where the program is implemented. And we have here some variables regarding the prices of expenditure of food, because again here, and this brings me to the remark of Hala, that we don't have we are tackling expenditure, so we need to know how the price of the main food items would affect the expenditure of the household. So now let me add these covariates to my regression. Just one thing we will do, because the land area is very small and in decimals, so I will transform it. I will divide it by 100, and because it's very small, we have 0.00. We will add 1 and use the log form again to reduce the variation. Okay. One thing, I mean, it can be useful in your research if you are doing a paper using diff and diff, and you want to see the how to say you make descriptive tables. You wanted to compare the different variables together. One interesting command is tab form, and again tab form is not built in STATA. You need to install it. I'm not even sure if it is installed in here or not. We'll see. So you can use tab form to compare between the different variables that we are including in our analysis. I will do it for the year before the implementation of the program in 91, to compare it between those who benefit from the credit and those who do not benefit from the credit. So let's see how it looks like. And this can be interesting for you to better understand the data. I mean, all the commands regarding the descriptive, the averages, comparing between the means, before running your regression, your diff and diff, it can be useful because it gives you a better idea of your data. It can also be if your results in your regression confirm what was found in your descriptive. So this means that you are, this was what observed even by just looking at the data without any comment. Let's run this. Okay, so here my tab form, I did not download it here. Let me show you. Okay, so SSC install tab form allowed me to install this command. Now let's run it and see how it looks like. So the command, you write tab form, all the variables of interest you wanted to include or you wanted to compare. Here I am adding the weight of the sampling weight to make sure that my results are at the Bangladesh level, at the country level, not only at my sample. I want to focus on the year 0, the year of 91, 92. I wanted to save the results into an Excel file, so I add it and I write its name. I give it a name. I want to differentiate between the households who benefit from the credit and the household who did not benefit from the credit, and I wanted to test the significance between both. Okay, so the file is not created. I don't know why. Sorry, let me check. Which is here. Okay, so here is the file. So this command provide or produce this table. So you can see that here you have your dummy variable that you create your analysis based on it here. by which is your treatment variable, those who are benefiting from a male credit program and those who are not benefiting from the program. Okay, you have 0 and 1. And then you have the average value of the different variables you include in your analysis, and if the difference is significant or not. So the only variables that are significant are the area of the land, and you see that those who are benefiting from the program have lower land area, and this a good sign, because this means that the program that was targeted was targeting the household who have a small area of land is doing a good job, because those who benefit from the programs are the ones who have a lower area of land. So there is no exclusion factor. I mean, those who are benefiting from the program are really the needy ones. Also, the gender of the household is significant. So the beneficiaries have mainly male-headed household. The age of the household head also is significant, but there's a significant difference between both. Those who are benefiting from the program are younger, their head are on average younger compared to those who are not benefiting of the program. But for all the other variables that are at the community level, only the price of the edible oil is different between both individuals. They are facing different prices. It's higher between those who benefit from the program. So this type of analysis is just because now we will include this variable in our regression, so we can see, we can expect simply by doing this table and doing this descriptive, we can expect that the variables that would have a difference or a significant impact on our variable of interest is the area of land, the head education, sorry, the head age, the head sex, and the price of edible oil. Any question? If you don't have any, please mute your mic. Okay, so we can also, so here I just, I mean, again, I will send you the do file, but just to show you. So here I did the same thing for also the female household, and you will find that the only also difference is the gender of the head, the education of the head, and the land. And for the community variables, we have the road, the access to road, and the prices. We can do it anyway. Okay, and let me take. So these are the variables for female credit programs. So here you can see that there are more significant variables. You have the area of land. You have the fewer males are mainly male in the programs, not benefiting from the program, and this expected. So the household who benefit from the female program have mainly female head. This means that they are more likely to take a decision in the expenditure, and they are the one deciding to get the benefit of the program and how you spend the income. You have also the education of the head. Among those who are benefiting from the program, you have lower education, which is expected also because the poor are usually with lower level of education. They have lower area of land. I don't know why I include the land twice. Regarding the community variables, you have the area of the land irrigated is larger among the households who, or the household who benefit from the program are mainly in villages where you have a higher proportion of land irrigated. Also, the price of milk and the price of eggs are affecting the expenditure of the household, which is expected as well, given that they spend on these food programs. Now let's introduce these variables. Sorry, before introducing this variable, one thing that we, I mean, in addition to understanding this, to see the variables and the distribution of these variables, what is significant or not, it shows you, given that we find that the poor are, or the one benefited from the program are the poorest one, the one with female head, the one with lower education. So this means that we are not really having a random context, that the program is, the selection into the program is affected by these observable characteristics, in addition, of course, of the non-observable characteristics that we talked about. One thing also you can do that you can compare how the difference between the different variables evolve over time. I mean, here we were doing this pre the implementation of the program, but one interesting thing that you can create a dummy variable that take into consideration not only if the individual is benefiting from the program or not, but also if the we are in year 0 or we are in year 1, and then you compare this. So I will create this new variables. Group M is interaction between the year and the fact that we have a treated male in the household. Group F is interaction between year and having a female beneficiary of the program in the group and in the household, and I will label them. Okay. And I will do the same thing to compare between both. Okay, let's return here. So here you see that we have, so instead of having only treated and non-treated, I created this interaction between the treated and non-treated and the year. So you have the control group in 91, the control group in 98, 01, year 0 and year 1, treated group in year 0, treated group in year 0, treated group in year 1. And again, you can see that we can have even changes over time. So for instance, for the control group, in year 98, the area of land is not significant anymore. There is no significant difference. For the gender of the head, no, it is a significant variable in affecting the total expenditure per capita. I mean, I cannot really conclude that it's significant variable in affecting the expenditure per capita, but I can say that there is a difference between the different households based on the gender of their household over the years. This is the only variable with the price of rice that is changing not only between the control group and the treated group, but also between the different years. Okay, now I will run the full model to see how can these variables affect the total expenditure per capita. But keeping in mind, again, that our variable of interest is the interaction between the year and the treatment variable, and this is the beta that we will be interested in studying. So I will run the regression. I keep in mind that I am adding the weight because we'll see when we'll add the PSM. And here we have the full model. Did the inclusion of the explanatory variable affect the results regarding the effect of the model of the treatment of our microcredit program on the total expenditure per capita? Again, I will repeat my question. When we did a regression only including the year and the treatment dummies in addition to the interaction variable, as Rihan mentioned, we did not have a significant effect of the beta of the variable of the interaction, which means, in other words, that our microcredit program for male has no significant impact on the total expenditure per capita of the households. Now we include other observable characteristics that we believe that can affect the expenditure of the household. My question is, by adding these observable characteristics, did the conclusion regarding the impact of the program on the total expenditure per capita different or not?
It's
No,
the
it's
same
still
effect, it's robust.
insignificant.
The same is what? Sorry, I didn't.
It's still insignificant, but I'm not sure about the magnitude. I don't remember the other coefficient, but it's still insignificant.
Exactly. The most important thing is that it is still insignificant. So this means that yes, it's true that this program targeting male is not significant in affecting the expenditure. And you can commenting on the other variables that you include to see. So for instance, as we mentioned, education of the head and the area of land of the household would affect the total expenditure per capita. But your main conclusion about the program, your recommendation to the policymakers in Bangladesh would not change. Let's see for the female credit. I will do the same thing. So if you remember, the female microcredit program had a significant effect on the total expenditure per capita of the households. Now we added other regressors that we think that it is not that they are affecting the total expenditure per capita. Did the effect of the program change now? The significance of our coefficient beta changed?
Yes, it becomes insignificant.
Yes, it become what? Sorry.
Insignificant. It's not significant anymore because it's
Exactly.
0.33. So after controlling for other variables, it's no more significant.
Exactly.
Not
So
robust.
that, as you mentioned, when controlling for other variables, it is not significant anymore, which means that we have other variables that are more significant in explaining the total expenditure per capita than this program. Like, for instance, the head education or the area of land or the price of milk or price of eggs. So this is also important that you need to control for the other variables that you believe that would affect your outcome variable of interest. So what we were talking about, the observable characteristics. And if you did not, now as your beta is not significant anymore, this means that being member or benefiting from the female credit program is not really the major or key factor in affecting the total expenditure per capita of the household. So this is why it was important to include all the observable characteristics and making sure that you are controlling for all observable and non-observable characteristics before providing any recommendations to the policymakers, because here, as you see, it is not significant anymore. Any question? Is it clear? Okay.
Yes.
Now let's see how we can do it if we wanted to use a difference on cross-sectional data. So instead of comparing between years, as we mentioned, we compare between program and non-program villages, and we have this information. And instead of comparing between participant and non-participants, I will compare between targeted and non-targeted. So I don't really focus on those who benefit, on those who can be targeted by the program, even if they did not benefit. So if I will return to your question, Noha, here in the beginning of the do file, I told you that we have 24 villages targeted and 5 villages not targeted. So here this instead of the time, and we have the criteria of selection of participation in the program. So I will not really, for the villages where the program was not implemented, I don't have beneficiaries, but I have individuals who has the criteria that would allow them to benefit from the program if the program was implemented in their village. So those will be the ones who I will consider as if they are treated. Okay? Let's see how it looks like in our data. Okay, it's here. Let's see this question. As a conclusion, the program of female has no significant effect. We cannot say it's not positive because saying it's not positive means that it is negative. No, it has no significant effect. If you control for all the other variables, observable characteristics that can affect the outcome variable of interest, which is expenditure per capita, we can conclude that having a female beneficiary of the microcredit program has no significant effect, whatever positive or negative, has no significant effect on the total expenditure per capita of this household. Okay, so here I will, because I manipulated the data, so I will open it again, the original one. So remember, we have a village and we have what we call STATA ID, which is how to say, it's sub-district, or smaller than the village but more than the individuals and then the household. If I show it to you, you see that we have village. Sorry, it is the opposite. The SANA is larger than the village. So we have the SANA, and these SANAs are divided into villages. I wanted to create one identifier combining both the SANA ID and the village ID. And here I have the household ID. So this is what I will do with this command. We will generate a new identifier that would combine the SANA ID and the village ID. And you can do this by, because it is a number, I will multiply the SANA ID, which was 1, 2, 3, as we saw, by 10, and then I will add it to the village ID. I will show you how it looks like. I always like to open the data set to see at least the beginning of the data, to see how what I did was created. Okay. Oh yes, I have a point, and this one was supposed to be. Okay, so here I have the SANA and the village ID. I created an identifier for both. So here I know that this household is living in SANA 1 in village 1. This one is living in SANA 1, village 2. This one is living in SANA 2, village 1. Of course, the SANA and the village have names, but here we are using only the codes, the numbers. So now I have the village SANA identifier. If I return back to my do file, I will create the log expenditure per capita. I will also adjust the household land area as we mentioned. Okay, now we wanted to create, remember, when we use diff and diff with panel data, I create a dummy variable for the year, 1 for the year after the implementation, 0 for the year before the implementation, and I create a dummy variable for the interaction between the year, and I create a dummy for the treatment, 1 for the treated individuals, 0 otherwise, and the interaction between both. Now I don't have time and I don't have beneficiaries. I have targeted village and targeted household. So I will start with the villages, which is considered as the time in the case of panel data. So here I will create a variable. I will call it target. Target equal 1 if the area of land of the household is less than 50, because this is a targeted group that, as we agreed, that the program, microcredit programs for male and the microcredit programs for female, target the households who have less than 50 decimals, or like half acre, which is 50 decimals. So I create this variable. Let me show to you. I will create this variable. So you see it is created here, target. If I make tab target, we have 0 and 1, and we can see the area of the land. You see for the households who have target variable equal 0 have large area of land. Sorry. While when we between 50 and 4618, while when for those households who are targeted have lower area of land. So this is my treatment coefficient, also my treatment dummy. I have the targeted village are those because remember, if I will come to the beginning of the do file, we said that the criteria of selection for the household is 1/2 acre of land, and we have 24 SANAs who are benefiting from the program, and 5 are not targeted. And we know the information, I mean, from the readings of the policy for Bangladesh, that the first 24 SANAs are the one who are targeted. So they sort the SANAs, and they took the 24 big, the first 24 ones, and these are the ones who are targeted by the program. So I will return here if I find it. Okay. Yes. So this target was the dummy variable for the treatment. Here is a dummy variable for the year, but I don't have year, I have village. So I create this variable gen program village, prog village, for the SANAs who has a number less than 25, the first 24. Okay, I will run it. You can see that here it was created, program village. Now, okay. Now I will create the interaction between both, because we need the interaction between the time dummy, which in our case here is a program village dummy, or the dummy that are reflecting, the dummy that is reflecting if the village is targeted or not, and the treatment dummy, which is in our case if the household was targeted or not. So this So this is my variable of interest, my diff and diff variables, which coefficient will let me know if this program has a significant effect or not. And I will run it. Okay. Now we will run the same model. We'll regress the total expenditure per capita on the program village, which is the year dummy, on the target, which is like the treatment dummy, and the interaction between both. What can we conclude from these results?
No effect as well.
No effect as well. And it is expected, because we already found that the programs of male are not significant, as well of females. So here, I mean, it's expected that we found that there is no significant effect. However, the target, I mean, the household who are eligible for the program, in case they benefit from the program, they will have lower total expenditure per capita. So here you see how you can create or apply diff in diff if you have cross section. And of course, you can also regress on the other explanatory variables, other regressors. I forgot to tell you in the previous one, because we have some variables at the village level, and here the dummies are created at the village level. We have to cluster at the village level, because to correct for the standard errors. So here I include the other explanatory variables, other regressors, and still we can see that our famous diff and diff coefficient is not significant. But again, I mean, even if we can apply diff and diff on the cross-section data, is not always easy to implement, given that you need to know. I mean, here it was easy because we know what are the villages that are eligible to be benefiting from the programs, and what is the cut-off criteria. Let me return you to the example I gave you yesterday about my joint paper with Marina Hasham and other colleagues from Cairo University and Paris 1. We had one of these comments from the reviewers that the PSM is not taking into consideration the unobservable characteristics. But we cannot apply diff in diff because we have cross-sectional data, and because in our case, the treatment is violence against women. So I cannot really say that cities as Cairo and Alexandria will be targeted for violence, while the other cities not. Here it will be difficult for us to define what are the villages or the cities or the households who are eligible to have a victim, women, and others who are not. So it's not always possible to implement it, but if you have the criteria that would allow you to create the villages or the groups who are benefiting and those who are not benefiting, you can apply it. Okay. Any question till here?
Yes, please, Dr. Rasha, I need just to be sure about the dimensions. If I understand well, the dimension of the cross-sectional difference in different for program, non-program, it replaced the time dimension. No, program and non-program village. It
Yes,
replaced the
exactly.
time
The village,
dimension.
so the village where, I mean, if you know, for instance, in Egypt, the new universal health insurance is implemented in 5 governorates initially. So you know that these are the villages that will be time T1 because these are the one where the program is implemented, and the other governorates, you know that they are not implemented. So here you can reproduce your year 1 and 0.
Okay, and in the program village or where the health insurance is implemented, all the population will be my target group, which means I'll compare for anyone the difference between before and after the program. However, for the non-program, all of them are non-targeted. So why I need the cutoff? That's what I was thinking about.
Okay, yeah, this is important question. You say something, Rams, that not exist. You said that for the governorate where the program is implemented, all the individuals are targeted, and I can compare them before and after. But if you have a cross
Yes.
section, you cannot compare before and after.
Ah,
Okay.
okay. Yes.
The problem that, I mean, I know that's confusing because I'm giving you an example on a panel data, but think about
Mm-hmm.
we have the household expenditure survey in Egypt. Uh,
Mm-hmm.
this program, I think, I mean, this universal health coverage, I think they started in 2017, and they started by 5 governorates, which I don't remember any one of them except Port-Said. Okay, so
Mm-hmm.
don't have in the household survey, it's not panel, so you don't have the information of those individuals before the implementation of the program. So you have a cross section. If you wanted to use diff and diff, so the first thing you say, okay, instead of the years, I will differentiate between the governorates where the program is implemented, which is Port Said and the 4 others. This would be
Mm-hmm.
as if T of time equal 1. And for all the 20 other governorates, we don't have this program implemented. So this as if T of time equals 0. Okay?
Mm-hmm.
So this is the years.
Okay.
Now you wanted to do the treatment. You don't know.
Mm-hmm.
I mean, in Port Said, you know who is benefiting and who is not benefiting. But in the governorates where the program is implemented, which as if the T equals 0 of time, you don't have someone who is benefiting of the program. However, you
Yes.
have the criteria that the government of Egypt implemented and say, if you have this criteria, you can benefit from this program. This is equal to the cut-off point here. Okay.
Okay.
So
So,
assume that the governorate of Egypt said, okay, those who are benefiting of this insurance should be working as wage worker or self-employed. But if you are not employed, you cannot benefit from the program. In this case, in the governorates where the program is not implemented, which equal to the time year equals 0, for you, the treated ones will be anyone who can benefit of the program if the program is implemented, which means that anyone who is working in the as wage worker or self-employed. Okay, and
okay, I'm
also
comparing who is eligible and non-eligible. That will be the difference in this case.
exactly, because
Okay.
it will not be really beneficiary, it will be eligible or have a selection criteria. And this is why here we use the cut-off point of the land. So now in each governorate, the one where the program is implemented, as if the time is 1, the other one is 0. And for the treatment, you have those who are eligible and those who are not. So you can make the difference between both and do it. But again, as I told you, here you can do it because you know where the government started by implementing. But if I want to do the same thing for violence, yes, maybe I can say, okay, for the eligibility, though all women can be victim of violence. I mean, this is in the literature of violence against women, whatever the education, whatever the age. Yes, maybe some women are more likely to be victim compared to other, but still I don't have eligibility criteria. And also I don't have the places where I am sure that the violence will happen here and will not happen in the other one. So it would be more difficult for us to use this diff and diff in this case. Here I cannot really differentiate between groups who cannot benefit of or cannot be victim of this. Okay? Is
Thank
it
you so much. Thank you.
my pleasure. Okay, the last thing we'll see together today is getting benefit of the two methods using diff and diff in addition to the PSM, which will make you get benefit of the two methodologies and control for any selection bias related to observable characteristics or not unobservable time invariant characteristics. PSM with diff would allow you to remove any observable heterogeneity in the initial conditions. Again, I will reuse my data set. I will create again the land adjusted as we mentioned. I will create a dummy variable for the treatment. Here I rename I create the interaction between the being treated, having a male credit program and being in the year, the dummy of the year. So I am created all these variables. And I will focus on. So here we will do the PSM on the sample of 1990 because I wanted to match the individuals in the original year, in the year 0, because okay, I know that in year 1 both I will compare their outcome, their expenditure. So in the beginning I wanted to match them based on their initial characteristics before the implementation of the program. This is why I will only keep the year 0, which is the initial year before the implementation of the program. And now I will estimate the PSM, and here I will use another command that I told you about it yesterday, but I did not run. It's the command pscore. What we used yesterday is the PS match 2, but here it is pscore. I mean, you will find it in the do file. I have the same. You will have it in the data set of yesterday, but I didn't want to show it yesterday. I want to show it you today just to change to have several methods of calculating the p-score. So the same thing, the p-score, I will include p-score. Then you have the variable that is your treatment, which is having a male microcredit program. You have all the characteristics that you believe that can affect the selection into the program. Then you calculate p-score and you save it in a variable called score, which is your probability of being selected into the program. From the options of the program block ID, it will divide the sample in blocks with similar values, with similar means, and when you add com support, it will calculate the score and keep the individuals who are on the common support. As you remember, the blue line of our density function yesterday, those who have equal scores, some of them had been selected and others had not been selected. So I wanted to keep only those common values of the p-score, and I wanted to do it as a significance level of 0.01, and it used it will calculate here the score, and then we'll see for the merge. So let's see how the command looks like, how the results of the it's not sorry, so we need to so again, as you see, all these commands are not built in STATA. Sorry. Not sure if it is downloaded or not. Okay. I can't find how we download it. I'm sorry for this. Okay. Okay, I cannot find the command to download it, so let's do the PS match to create the P score, and then you can download it when you work on it. Yes, you cannot, well, this is my mistake. You cannot use this separators here. Here our variable of outcome variable is the total expenditure per capita, which I cannot find. Yes. Why it is not found? Okay, let's do it again. One other option that you can do, so you can use PS match or P score when you download it, but another option, let me just first check this one. Okay. So here we use the PS match too, and if you remember, it create already the P score. So you can use this P score for your weight that I will show you now how you show it, if you remember. So these are the scores predicted by the PS match 2. You can use the P score command when you download it, or you can do as we did yesterday, that you just use a probit or logit regression, where you regress your variable, your treatment variable on all the observable characteristics. Then you predict your P hat, and then you use it for your weight. So you can do any of the three methods. I wanted to show you the P score, but I'm not able to download it now. But if you use it, it can be the same thing, and you'll find it in the do file. So after calculating the P score, now I want to how to say, to use this P score for calculating the weight that I will be used in my regression, right? Which is my diff and diff, because now I have this probability of being selected into the program in the year 0, which will allow me to match between the beneficiaries and non-beneficiaries, which will allow me to exclude any heterogeneity. And then when I will use diff and diff, it will be more accurate. I would keep all the in this data, because here I'm keeping only the year 0. I don't have year 1. I want to keep from this data the value of the score and the household number to be able to merge it later with the sample where I have year 0 and year 1. So let me just rename the P score by score, because all the commands after are named like this. Okay, and now in this data where you have year 0 and the score, I will keep only the household identifier and score. So if you see your sample now, here you have the household identifier and you have the score, which is the probability of being selected into the program of male microcredit based on the characteristics of observable characteristics that can affect this selection. Okay. Is it clear this step? I know there was a little bit of confusion. So is it clear here? I did not confuse you. I assume that it's clear. Now I will merge this data set where I have the score for each household with the original data set, because all I wanted is to create this score to be able to match the individuals, the households, but I created based on the initial year, and I want to add these values, the scores into the original data. So I will merge both. Okay, I have 1,652 observation match because I create the p-score for everyone in my data set. Installing. Okay. Thank you, Noha. I will use it after, because I did not use it here for a long time. So let me add it to the do file also for the future generations. Install case 4. So here I merge the household, the p-score value with the original data set. Keep if merge equals 3. Okay, and now I will create the variables of interest I'm interested in, the total expenditure, the land, the interaction variables for all the variables I need for my regression. Okay, now this is a step that would differ. Remember yesterday, after calculating the score, we calculated the inverse propensity score. You remember, which is the treatment variable divided by the p-value hat plus 1 minus the treatment variable divided by 1 minus the p hat. If I return to the presentation from yesterday, you remember we said if we wanted to use the PSM as weight, we will calculate this weight, which is a treatment over the estimated score for the treated household plus 1 minus the treatment dummy divided by 1 minus the estimated score. So here I am doing the same thing as we did yesterday. The only thing here different that I did not do yesterday, because yesterday I didn't have weights. In our data here, I have a sampling weight, which allowed me, whenever I'm doing any command, to do it at the household, at the population level, not only as a sample level. So in addition of creating the p-score weight based on the PSM value, I will multiply it by the sampling weight of my sample to have both weights into consideration. The sample weight, which is important for sampling and for reflecting on the whole population, in addition to the inverse propensity weight. I will multiply both together and I create new weight, which I call the T weight underscore F, because here I'm doing this analysis for women. Are you following with me, or I missed you already?
Yes.
Okay. So here I created the p-score, I created the weight, I multiplied the weight by the sampling weight of my sample, and now we will run the regression as exactly what we did in the beginning of this session. I will regress my outcome variable of interest on the year dummy, on the treatment dummy, on the interaction of the two dummies, on all the explanatory variables. But the only difference, I will benefit from the score of the PSM in the weighting. So in the weight, instead of using the sampling weight, I will use the weight I calculated with the sampling weight and the p-score. And I will run the regression. And here, what can we conclude regarding the female credit program? Does this program have any positive effect on or significant effect on the total expenditure per capita of the households?
Still insignificant.
Still not significant. So here I am pretty sure that this program really has no significant effect, because it's not only I'm using diff and diff, but also I match between the individuals in the original year by the PSM method. So we are sure we can conclude that this program has no significant effect on the total expenditure per capita. And here we are sure that we controlled for both the observable characteristics using also the PSM. I exclude any heterogeneity that can exist in the beginning, in addition to the observation to the unobservable time in varying characteristics by using the diff in diff. And here you can use both together. And on this we are done